Assalamu alaikum wa rahmatullahi wa barakatuh. My name is Jamal Ahmed and I am chemistry teacher. Today my topic of discussion will be limiting reactant. I prepared three topics but I will explain only one topic, and that is what limiting reactant. Okay, so what is limiting reactant? Basically, we will describe it by using this definition. The definition is the reactant in a chemical reaction which gives least moles of the product. So we know that in a chemical reaction, different reactants are involved when a chemical reaction takes place. So the reactant in a chemical reaction which gives the least moles of the product and consumed completely, that will be called what? Limiting reactant. So we can explain this definition by using different examples. First of all, I will give this example: formation of water molecule. If we take hydrogen 2 moles and 1 moles of oxygen, then we will get what? 2 moles of water. Right? This is a balanced chemical equation. So we call it stoichiometric calculation. In the above example, you will see that none of the reactant is the limiting. Why? Because all of the reactants will convert into product. None of the reactant will be left behind. So from stoichiometric calculation, we cannot determine that which reactant is a limiting reactant. So what we have to do, we will just improve or enhance the number of moles of one of the reactant. Let's suppose I increase the moles of oxygen from 1 to 2. So what will happen basically, 2 moles of water will be formed and one of the reactant will be left behind and one of the reactant will completely consume. The reactant which left behind will be oxygen because we take 1 more mole of oxygen. So that's why the hydrogen will be called what? Limiting reactant in this example. And that calculation will be called what? Non-stoichiometric calculation. Means imbalanced equation. So if the equation is imbalanced, then what? We can determine that which reactant is a limiting reactant. Then we will take another example from our common life. Here I gave the example from daily life. Example is of formation of sandwiches. Let's we consider that sandwich are the product, and we have 2 reactants, that is kebab and the slices. If we have 4 kebabs, let's suppose, and we have 10 slices, then how many sandwiches we can make? There are 4. Because in order to make sandwich, we required what? 2 slices and 1 kebab. So we required how many kebabs? 4 kebabs, and we required how many slices? There are only 8. So 2 of the slices will be left behind. So here we take a common example. So here in this example, I wrote over here that kebab will be what? Limiting reactant, because they are completely consumed. Because we have only 4 kebabs and we have 10 slices and we are going to make 4 sandwiches. So all 4 kebabs will be used, completely consumed, and what? 2 slices will be left behind. So slices will be called what? Non-limiting reactants, and what? Kebab will be called what? Limiting reactants. So in this example, we will conclude that kebab will be the limiting reactant. Okay, next we will do what? Next we will do perform some steps in order to calculate which reactant is the limiting reactant, because we are dealing with the chemistry. So that's why we will take the example of any one example in which we will use reactants which will be used commonly. So here, first of all, what we will do, we will calculate mole of each reactant from the given masses of each reactant, because in the example, the question will arise that these are the masses of the reactant. First, you will do what? You have to calculate the mole of each reactant. The second step, you will do what? You have to compare the mole of each reactant with the mole of the product. So next we will do what? We have to compare the mole of each reactant from the moles of the product. Then we will do what? Reactant which produce least moles of the product, that will be called what? Limiting reactant. So one of the reactant which produce least moles of the product, that will be called what? Limiting reactant. Like I take the example from the textbook, that is what? A mixture of 2 liquids are used, that is hydrogen and 2O4. In order to make a fuel which are used to prepare a fuel in rocket. So they produce what? Nitrogen how much? N2, and water what? and also they will form water, how many grams of nitrogen gas will be formed? It is asking over here by reacting 100 gram of N2H4 and 200 gram of N2O4. So the question is what basically the two reactants are utilized and these are the two products which are formed. So first we will make what? A balanced equation, and then we will perform our next calculation. So in the next slide I will give you how we will find mass of nitrogen. So first I told you in the previous slide that what are the steps we have to perform. First of all we will do what? We will calculate the molar mass of N2H4. How it is obtained? This is a basic example from your previous knowledge. Let that there are 14, the mass of nitrogen is 14, so 14 multiplied by 2 plus 4 multiplied by 1, and then we will add them, then the obtained mass will be 32. Same as it is number of moles of, if you want to calculate N2H4, so in the question they have provided 100 grams of N2H4. So then when we will divide the molar mass of N2H4 from the 100, then we will get what? The moles of N2H4. Similarly, we will calculate for N2O4, that will obtain what? 2.174. From balanced chemical equation you can see over here. So we will compare. Basically the first step was to calculate the number of moles of each reactants. The second step was what? In the previous slide I told you that we will compare the number of moles of reactant and the product. So the product was nitrogen, so we will compare N2H4 with nitrogen and also N2O4 with N2. Here we will see in the balanced equation that there are 2 moles of N2H4 which are going to prepare what? 3 moles of nitrogen. So first we will do what? We will make it 1 because we have to calculate that from this number of moles of N2H4 how many number of moles of N2 are produced. So that's why we will make it what? 1. How we will make it what? By dividing 2 from each side, from either side. So we will get what? We will get the number of moles of nitrogen for this moles of N2H4. Similarly, we will calculate for N2O4. From balance equation, first of all, here you can see 1 mole of N2O4 are going to produce 3 moles of nitrogen. So 2.174 moles which are over here, they will produce how many? We will multiply 3 by 2.174, you will get what? This moles of N2. So it means that if you see over here that this reactant N2H4 are going to produce 4.6875 moles of N2 and N2O4 are going to produce 6.522 moles of nitrogen. So which reactant is producing least number of moles of product? That will be called the limiting reactant, and here you can see that 4.6875 are going to produce N2H4, so that's why these are the least moles of the product. So that reactant will be called what? It should be called limiting reactant. So if you want to find the mass of nitrogen, then we will use this number of moles of nitrogen, not this number of moles of nitrogen. So what we have to do in order to calculate mass of nitrogen, we will use what? Its molar mass, that is 28, and its actual number of moles of nitrogen, that is 4.6875. When we will multiply these two, then we will get what? Mass of nitrogen, that are what? 131.18 grams. So you can calculate like this by using your technique, that is limiting reactant, the actual number of moles of product. So this was my today's topic. Thank you so much, and hope so inshallah we will meet next time with the next topic. Thank you. Assalamu alaikum.